Okay, let's see more examples. And again, all of these examples are at the level of Calc 1 integrals. So we do them for just a review and refreshing your mind to be prepared for more advanced integrals that we are going to do later. So the integral of 1 over radical x, as with other examples, I suggest that you pause the video and try to do this on your own before watching my solution here. Okay, so as we know from basic algebra, radical x is x to the power of 1/2, but here is 1 over radical x. So 1 over radical x is x to the power of minus 1/2. The reason that we need to write a 1 over radical x as x to the power of minus 1/2 is to use the power rule. Now I have x to some power, and that power is minus 1/2. Using the power rule, this is going to be x to the power of minus 1/2 plus 1, which is positive 1/2, divided by minus 1/2 plus 1, which is again positive 1/2, and then plus c. Dividing by 1/2 is the same as multiplying by 2, right? So I can write this as 2 times x to the power of 1/2. And we know that x to the power of 1/2 is the same as radical x. So 2 radical x plus c is the answer to this indefinite integral. So 2 radical x plus c. And as you know from Calc 1, for the indefinite integrals, we always have plus c at the end of our answer. Let's do another example. Suppose I had the same function, but the integral was a definite integral, and I want to find the integral from 1 to 3 of 1 over radical x dx. So at the end, I want a number, uh, but I want an exact answer, exact number, exact value. What does that mean? It means that if applicable, definitely we need to simplify, but we don't use a calculator to give a decimal approximated value. I need an exact value. For instance, if in my answer I have a radical 2, that radical 2 remains there as an exact answer. Or if I, in some problem, if I have a number pi as an exact value, pi remains in the answer. Or if I have irrational number e, that e remains in the answer. But of course, we need to simplify our answer. If there are things that can be simplified, we have to do that, but we never use a calculator to give a decimal value if the question specifies it requires an exact value. Again, try to find this on your own, as we did with the previous example, that this is x2 minus 1/2. Antiderivative was, as we found in the previous example, it was 2 radical x plus c, but since we are dealing with a definite integral, no plus c required here. And it should be evaluated at these limit numbers of the integral, and we should do the subtraction. So this means that 2 radical x evaluated at 3, which is 2 radical 3, minus the evaluation of this function at 1, 2 radical 1. Obviously, radical 1 is 1. We don't leave it as radical 1. But radical 3, I can't do anything about that as an exact number. So the final answer is 2 radical 3 and minus 2. So that's the answer that we type in here, 2 radical 3 minus 2. Another example. Again, this is kind of examples as with other examples that we have done so far that you have seen in Calc 1 or similar things you have seen in Calc 1. The integral of x squared plus 1 all over x dx. That's a that's an indefinite integral, so in the answer I have plus c. So first of all, we try to split this fraction as two fractions. X squared plus 1 over x can be written as the sum of two fractions, x squared over x and 1 over x. So since we have just one term at the bottom and two terms on the top, I can split the fraction in this way. In the first term, x squared over x is just x. So I have the integral of x plus the integral of 1 over x. You know that from Calc 1, when we have the sum of two functions and we want to integrate, we can split the integral as two integrals. So here, integral of x plus integral of 1 over x. Using the power rule, integral of x is x squared over 2. But what was integral of 1 over x? It was ln of absolute value of x. This is something that I reminded you in the previous video. So at the end plus c. So that's the final answer that we need to type in here. Similar to this, let me give another example. Again, try to do this on your own before watching my solution. The integral of x squared plus 1 over radical x dx. Okay, so again, I see that the denominator of the function is just one term, and we have two terms on the top, so I can split the fraction as the sum of two fractions. So first of all, what is x squared over radical x? How can I simplify it as x to some power? This is something in basic algebra. You have seen things like that, so that can be simplified as x to the power of 3/2. So x squared over radical x is x to the power of 3/2. And as we saw in one of the previous examples, 1 over radical x is x to the power of minus 1/2. Okay, now I can integrate each of these two functions, one of them x to the power of 3/2, and the other one x to the power of minus 1/2. Integral of x to the power of 3/2 using the power rule is x to the power of 5/2 divided by 5/2. But dividing by 5/2 is the same as multiplying by 2/5, right? The other one is familiar to us. We just have 2x to the power of 1/2 plus c. This is a valid answer, so I can stop here. Or you might use radicals to show the function. That's also acceptable. So this, or I can write this as, again, using algebra. X to the power of 5/2 is the same as radical x to the power of 5. And as we saw before, x to the power of 1/2 is radical x and plus c. Either one is good. You can choose either of these two as the answer. So let me just write the first one up there. So 2/5 times x to the power of 5/2. So 5/2 is the exponent of x plus 2 times x to the power of 1/2 and then plus c. Let me make a reminder on the integral of some trigonometric functions. As you know, just as a reminder, since the derivative of sine is cosine, in terms of integrals, the integral of cosine is a sine because the derivative of sine is cosine. And since the derivative of cosine is negative sine, it means that the integral of sine is minus cosine of x. Now, let's do this example that I want to find the integral of 2 times sine x plus 3 cosine x dx. Again, try this on your own before watching my solution. So here first I split this integral as two integrals because they have been added to each other. So the integral of 2 sine x plus the integral of 3 cosine x. As you know, if there is a constant multiplied by a function, the constant can be pulled out of the integral. This is one of the properties that you have seen in more details in Calc 1. The same thing for this integral. 3 is a constant, so it can be pulled out of the integral. But be careful that the variable or any function containing the variable cannot be pulled out of the integral. Just constants can be pulled out of integrals, which means that we have 2 times integral of sine x plus 3 times integral of cosine x. And by that reminder that you see on the top, antiderivative of sine is negative cosine. So this part is negative cosine. And antiderivative of cosine is sine. So the answer that we are going to type in here, 2 times minus cosine or minus 2 cosine x plus 3 times sine x. And don't forget plus c at the end because here is a problem of an indefinite integral. So we need a plus c at the end.